In this lesson, we shall look at integers, and an integer is a whole number that can be negative, positive, or zero. The set of integers contains whole numbers and their negative counterparts. So we already saw whole numbers, which start from 0, 1, 2, 3, and so on. Now integers are also whole numbers, but for them they could be negative or positive. So if I was to write the set of integers, normally denoted as Z, it would be -3, -2, -1, 0, 1, 2, 3, and other members. So we could see that the set of integers has so many elements that are actually uncountable. So that means that the set of integers is an infinite set. In other words, it contains an uncountable number of elements. We cannot exhaust integers. As we count them, they go from one side of the number line to the other. There are so many, we cannot count them. We also need to know that integers cannot be fractions. Integers cannot be fractions. They're always whole numbers. So 2.5 and maybe 3.6, maybe 4.8, or even a third, maybe a half. All these decimals and fractions, these ones here cannot be integers. Integers are first of all whole numbers, but they can be positive, they can be negative. Let's represent integers on a number line and see how they would look like. So if this was my number line, then of course we know this is, the middle point is 0. So on this side we have positives, 1, 2, 3, 4, 5, 6, 7, and so on. On this side we have negatives, -1, -2, -3, -4, -5, and so on. So all these ones are integers. The number line can be used to indicate integers. All these ones are integers. They can move to the right of 0 or to the left of 0. So integers are negatives or positives, but 0 is the only integer which is neither negative nor positive. So that's how we could indicate integers on a number line. Let's look at how to multiply integers, rules for multiplying integers. Rules for multiplying integers. Now I'll demonstrate them like this. If a and b are integers, then if I have a times b, then the answer will be ab. In other words, when we're multiplying two positive integers, the result is a positive. Then if I had -a times -b, the answer would still be A, B. In other words, if I multiply two negative integers, the result is positive. Then if I had a negative times a positive, I'd get negative A, B. This means that when I multiply a negative by a positive, the result is a negative. We can memorize that like this. We could say two like signs become positive. And two unlike signs become negative. Two like signs become positive. That means if I multiply a positive by a positive, I get a positive, or a negative by a negative. As long as the signs are the same, I still get a positive. Then if I multiply unlike signs, a negative by a positive, I'll get a negative. This could be an easy way to memorize the multiplication of integers. Let's take a look at a brief example. We could work out the following. So if we have negative 3 times negative 7, these are same signs, so we shall get a positive 21. If we have positive 4 times 3, positive gives us a positive 12. But if we had negative 5 times 4, negative positive gives us a negative 20. So that's how we multiply integers. Let's look at how to divide integers. If A and B are integers still, so if I have A over B, the result will be A over B, a positive. So when I divide two positive integers, I get a positive. If I had negative A out of negative B, it would still give me a positive. So negative divided by negative is positive. Then if I had negative A out of B, it would give me a negative. Doesn't matter whether the negative is up or down, you will still get a negative. So the same idea we used in multiplication also applies in division. Two like signs become a positive. Two like signs become a positive, and two unlike signs become a negative. Two unlike signs become a negative. So we could take a very brief example. Work out string. So if I have negative, maybe I have positive 20 divided by 4. The answer is 5. Positive. Positive divided by positive is positive. If I had negative 100 divided by 10, negative divided by a positive is a negative. If I had maybe negative 50 out of negative 5, a negative divided by a negative is a positive. So the idea still works. When the signs are the same, it's always positive. When the signs are different, it's always negative. It doesn't even matter whether the sign is up or down. Because if I have maybe 12 out of negative 3, the answer will still be negative 4. As long as the signs are different, the result is a negative. As long as the signs are the same, the result from division is always positive. Let's look at briefly addition and subtraction of integers. Addition and subtraction of integers. Now, there are no specific rules for adding or subtraction of integers. The result from addition or subtraction depends on whether the negative is bigger than the positive or the reverse is true. For example, if I have 20 plus negative 5, this becomes 15, a positive. If I have negative 5 plus negative 12, when you add two negatives, you get a negative. So the answer is negative 17. Then when we have positive 4 plus positive 8, answer is a positive. When we add a positive and a positive, we get a positive. When we add a negative and a negative, we get a negative. So we can note that addition of two negatives gives a negative, while addition of two positives, two positive integers, gives a positive. So we could have part D, which could be 10 minus 8. Answer is positive 2. Could have negative 7 minus 4. Answer is negative 11. We could have negative 10 minus negative 13. This turns into a positive. So this is negative 10 plus 13, which is 3. So there's so many numerous examples we could do, but that's where we shall end for this lesson.